Okay, welcome back. This is Mr. Hassan's Maths channel. This is a question from the October 2021. This is from the GCE A-level paper from the UK, from the paper 2 of syllabus 9MA02. This is from the Edexcel exam from the UK, and this corresponds to questions from P3 in the international A-level syllabus from Edexcel as well. So this is a question about the modulus function. It tells us about this figure 4, which shows a sketch of the graph with the equation y equals the modulus of 2x minus 3k. So all of this inside the modulus sign, where k is a positive constant. So that's an important point to note. Sketch the graph with the equation y equals f of x, where f of x is equal to k minus the modulus of 2x minus 3k, stating the coordinates of the maximum point and the coordinates of any points where the graph cuts the coordinate axes. Okay, so now basically, if we look at this graph here, or look at this equation here, we can work out from this where its vertex is, what shape it has, and we can also work out where it crosses the x and y axis in terms of k. So we can just look at this for all that information. And we should note that this is basically a transformation of this graph. It's going to be one upside down. Instead of having this shape like that does, it's going to have a V shape that's upside down. And secondly, it's going to be translated by k units upwards. 0k, you could say, 0k translation. So two things that are going to happen. So we can note that its shape is going to be upside down V shape, and its vertex is going to be up here somewhere. Okay. As for where it hits the x-axis, where it hits the y-axis, we can calculate that in terms of k. We know k is a positive constant. So that's what I'm going to do first. So I'm going to first of all figure out where this hits the y-axis. So we can say y-axis is when x equals 0. Everywhere on the y-axis, x equals 0. So when x equals 0, we can say y equals k minus the modulus of 2 times 0, which is 0 minus 3k. Now, when you have the modulus of something and it's negative, we know this is a negative value because k is positive. So minus 3 times k is a negative 3k. So it's a negative value. That's going to become positive in the modulus sign. So you have k minus 3k. Okay, k minus 3k, which is going to be minus 2k. All right. So we know that the k minus 3k. Okay, so yeah, so y is going to be minus 2k. That's where it hits the y-axis. So that's going to be 0 and negative 2k. Okay, it's going to hit the y-axis. So it's going to hit the y-axis down here, which kind of makes sense. It's going to come down like this. All right. Okay, that's one thing we can work out. And then we're going to work out also where it crosses the x-axis. Now it crosses the x-axis this time when y equals 0. Okay, now when y equals 0, we're going to basically equate this whole thing to 0. So we have k minus the modulus of 2x minus 3k is equal to 0. So we're going to solve this equation, okay, this modulus equation. So we can rearrange it first if you want. You can say the modulus of 2x minus 3k is equal to k. Just add this to both sides, you end up with this. And then we can say what this means is two possibilities. We can say either 2x minus 3k is equal to k, or 2x minus 3k is equal to negative k. And that's how the modulus equation works here, right? So now we can add 3k to both sides. So 2x equals 4k, and then divide by 2. So that's 4k divided by 2, which is 2k. Or we can, for this one, we add 3k to both sides again, but this time we'll have 2x equals minus k plus 3k, which is 2k. So therefore k is equal to, x is equal to 1k. So we know that it crosses the x-axis at 2k and 0 and at k and 0. And the vertex. Now, the vertex of this is going to be given by the y-coordinate, which will be whatever's there, which is a k. And the x-coordinate will be whatever makes this inside the modulus sign 0. Okay, so when 2x minus 3k is equal to 0, then 2x is equal to 3k. So x is equal to 3 over 2k. Okay, that's 3 over 2k. And we can confirm it also by you looking at the halfway between these two. Okay, halfway between these two, because it's symmetrical, halfway between those two will be the x-coordinate of the vertex. So halfway between 2k and 3k is 3k over 2, which is what we found there. That just confirms it. So now we can make our drawing, our sketch. So we can see here in our sketch that you're going to have your y-axis and you're going to have your x-axis. Okay, it's going to cross the y-axis at minus 2k, and the x-axis is going to cross it at k. So I'll just draw this part first. Let me just draw a different line. Not so thick. Okay, so it's going to go like this, and then it's going to go like this. Be symmetrical like that. Okay, so that will be our graph. Make sure that it's meeting there. Okay. So that's k, and that's 2k, and that's the vertex, which is 3k over 2 and k. Right, so this is your y-axis, this is your x-axis, and this is our graph of f of x. Y equals f of x. Okay, which is what this is called. Okay, so there we have the coordinates of the maximum point mentioned, the coordinates of the points where it crosses the coordinate axes, and that's our sketch. Okay, so that's, it should be the same kind of steepness as this, and maybe I made it less steep, but it's just a sketch, no problem. Okay, we've got the points that are important, cutting where it cuts through. We know that these are positive and this is negative because k is a positive constant. So when it's minus 2k, it's negative. When it's positive k and positive 2k, positive. So there we have the sketch of this graph, and we can see what's happened. Two things have happened. It's been reflected in the x-axis and it's been raised up by k units. That's why it's upside down and its vertex has gone up to there. All right, so that answers part A. Okay, now for part B. Find in terms of k the set of values for which k minus 2x minus 3k is greater than x minus k. Give me your answer in set notation. So I'm going to use the sketch. So let me just get that. So here I brought the sketch over from the other page. All right, so we've got to solve the equation, or the inequality, sorry, not the equation, the inequality where k minus 2x minus 3k inside the modulus is greater than x minus k. So if I want to solve this equation, or this inequality, I've got to first find the critical values. I've got to find when is k minus the modulus of 2x minus 3k is equal to x minus k. When do they intersect? Okay, x minus k would be a graph which is less steep than this one, all right? And it passes through minus k, and it passes through k as well. Passes these 2 points, because when x is 0, y is minus k. When y is 0, x is k. So it's going to be a graph that looks like this. So I can see one of the points where they intersect straight away. All right, so it's going to be a graph that looks something like this. Let me just make sure it goes to the right points. It's going to be something like this. Let me just do this and then extend it in both ways. So it's going to be like this. That's better. Okay, so this is the graph of y equals x minus k, this graph here. All right, so we can see that one of the points where they intersect is definitely at k0. Okay, when x equals k, right? And the other point is this point over here. Okay, and I can see that this graph is above that graph, is greater than that graph between these two values, between this value and this value. So I've got to find what this value is over here. Now, what is this value? Well, it's where this branch of this graph, which is y equals k minus the modulus of 2x minus 3k, meets this line. Okay, so what is this branch of this graph? Okay, well, we have 2 branches. You have the positive branch and the negative branch. The positive branch is when you have y equals, and you leave it as it is. So it'll be k, and you have minus 2x, and you'll have plus 3k. So that branch will be, move that out of the way first. that branch will be y equals minus 2x plus 4k. That's going to be this branch here because it's got a negative gradient. So this is y equals negative 2x plus 4k. And this branch will be the negative branch, okay, which we don't need now because we know that we know where it intersects, we can see it. But if we didn't know where it intersects, we would use a negative branch. And the negative branch of this graph is when you change the sign of what's outside it. So it will be k plus, y equals k plus 2x. And so that would be plus 2x minus 3k. Okay, because you change the sign of what's outside it, so everything else inside will be the same then. Okay, so that will be y equals 2x minus 2k, which is exactly what this is. Okay, this is the graph y equals 2x minus 2k. As you can see, it has a gradient of 2 and it goes through here at minus 2k. All right, so now we already got that. We already know where they intersect. So they intersect in two places. One of the places we know, and then we can confirm it algebraically if you want. We can say when 2x minus 2k is equal to x minus k, and we can see that you'll have 2x minus x equals minus k plus 2k. So you'll have so 2x minus x is going to be x equals k. Okay, which is that point there we know already, right? The other place where they intersect is over here. That's what we're interested in. And that's when this and that intersect, which is minus 2x plus 4k is equal to x minus k. So you have 4k plus k, which is 5k. 5k is equal to 3x. X plus 2x. So we can say x is equal to 5k over 3. 5k over 3, that's the point here. 5k over 3. That's where they intersect. So we can see, we want to find when is this modulus graph greater than x minus k. So when it is basically when it's above it, and we can see that it's above it in the region that we can see over here. Let me just change the color. So we can see that in this region here, this is where the modulus graph is higher than the normal graph. Where the modulus graph is like if you find a value of, when x equals this value here, the value on the normal graph is lower than the value on the modulus graph. So the modulus graph is greater than the normal graph in this area here. But if you choose a value of x over here, then you can see that the value of the modulus graph is less than the one on the normal graph. So we can see that the values for which this inequality are true are when k, between k is greater than, not equal to, when x is greater than, k, and less than, or not equal to, less than 5k over 3. Okay, so when x is between k and 5k over 3. Now they say give the answer in set notation. So we could write this in a couple of ways. We can say x is such that, and then we can write this, x is between k and 5k over 3 without the equal sign, because it says just greater than, it doesn't say equal to. Or if you want to, you can say x is such that x is greater than k, and intersection with x is such that x is less than 5k over 3. Both of those are correct. Okay, I prefer this, writing it like this, but this is also correct as well if you're writing in set notation. The set notation just basically have to have the squiggly brackets, and this x is such that, and if you want to put x is a member of the real numbers or something like that, that's fine as well. Okay, but that's the answer, or that is the answer. Both of them are correct. Intersection means and, right? So it's between those two values. So there's the answer to question number 11, part B. Next, we've got to do 11 part C. It says find in terms of k the coordinates of the minimum point of the graph with this equation y equals 3 minus 5 times f of 1/2 x. Now, f of x is what? F of x is this graph here. Okay, f of x is this graph here. Okay, this is f of x. So I'm going to take the equation for f of x, okay, which is k minus the modulus of 2x minus 3k. So I think, yeah, f of x is k minus the modulus of, it was 2x minus 3k. That's f of x. Okay, so the minimum point of the graph with this equation. So we can say the minimum point is going to be the vertex. Okay, now how do we know that the vertex is going to be a minimum in this case? Well, because you can see that the function has been multiplied by negative outside the whole function. So what was like this is going to become like this. So the vertex is now going to become the minimum. So let's find the vertex of f of x. So let's start with f of x. Okay, we'll think about what the vertex of f of x is. Okay, so for f of x, the vertex is basically the point, as we determined, it was 3k over 2k. 3k over 2 and k. Let's look at all the transformations that take place. We'll start off always start off with what's inside the function. So when you have what's it called, a series or combination of transformations taking place, you always start off with what's inside the function. Okay, all the horizontal transformations first, always. So we're going to start off with finding what f half x does. Okay, so that's the first thing. So the vertex will now become, under just this transformation alone, this is going to be a horizontal stretch of factor 2. The reciprocal of this, remember, it's inside the function, acts opposite. So this is going to be a stretch, okay, and it's horizontal. And the factor is the reciprocal of a half, which is 2. So that means the x coordinates are multiplied by 2. The y coordinates stay as they are under this transformation. So this is going to become 3k. That's under just the half f half of x. So we finish with what's inside the function. And by the way, if there was some other stuff inside the function, like you had to, if it was f half of x plus 2 inside, we would start with the opposite of BIDMAS. We would start with the plus 2, translated 2 units to the left, and then multiply by 2, and then we would go to the things on the outside. So now, when we are dealing now with things which are outside the function, we do things in order of BIDMAS, because this kind of outside is normal, right? So you have 3 minus 5 times f half of x. So the first thing I'm going to do with minus 5. I can do this in one step. Minus 5 times f half of x. So this part is already done. So I'm going to, that's already been taken care of. Now we're concentrating on this section here. So what happens here? Well, the x coordinate is untouched. So this stays as 3k. But what happens to the y coordinate? Well, it's multiplied by minus 5. So this becomes minus 5k. Okay, so there's two things happening here. It's a reflection in the x-axis, that's a minus part, and secondly, it's a stretch, which is vertical, of factor 5. That's what's happened. So two things in once, you could say. That's fine, you can do that in one go. So that part's done. Here we were dealing with just that part. Here we dealt with this part. Here we're dealing with that part. Now there's one thing left, which is basically adding 3 to it. This like minus 5 of all of this plus 3. So adding 3 to the whole function. So now we're going to do, I'll write it like this to make it clear, minus 5f half of x plus 3. It's the same thing as that. Okay, it's just I've written the 3 here to make it a bit clearer. So now we're dealing with this plus 3 part. So again, this is outside the function. And what happens to this? It affects only the part which is, the y coordinate. Because this is a vertical translation. This is a vertical translation and it's basically 0, 3. Okay, so the x coordinate stays as it is. And the y coordinate, which is minus 5k, you get minus 5k plus 3. So this is the final coordinate of the minimum point of the graph. it's 3k, and you can write it as 3 minus 5k to make it look neater. This is the answer. Okay, it's a minimum because it's turned upside down. Okay, when it was multiplied by minus 5, turned upside down. So now the maximum that was this becomes a minimum in the transformed graph because it's minus 5. And there's the answer to this question. Okay, on transformation. So this question involves absolute value, or you can say the modulus graph, and also inequalities in dealing with modulus graph, and also some transformations. Okay, a lot of things involved in this question. Other questions from this particular paper will be found in the playlist that will appear in this region over here. Other questions from P3 modulus functions can be found in the playlist over here. You can subscribe to my channel by clicking on this link. In fact, you'll have another playlist here dealing with transformations of functions, and you can subscribe to my channel by clicking on this link. And the card that appears at various times in the video takes you to a video which tells you how to use my channel effectively. Thank you for watching, and see you soon.